All right, this screencast is going to cover parts of, but not completely all of, Lab Exercise 5, Activity 3, where we start looking at the geologic time scale. It's a pretty interesting concept because it's so mind-boggling when we start looking at how old the Earth is. And we start talking about from hundreds of thousands into millions, and then we start using a number like 4.55 billion. So we're going to kind of take it slow. I'll kind of walk you through a couple steps, but I want to focus on this page right here. And you've got a couple different geologic timescales accessible in your textbook. But if I were to talk geologic timescale, it's hard for me to ignore the Precambrian. The Precambrian is an eon. These eons, as of right now, when we geologists break down geologic timescales, there's only two eons. We've got the Precambrian and we've got the Phanerozoic. We currently reside in the Phanerozoic eon. The Precambrian, because it's so much of time, if we look at just the Earth's geologic time, the Precambrian represents about 88% of all of Earth's life. In other words, really most of the Earth's life is found in the chapter of Earth that we call Precambrian. It's broken down into what's called the Hadean, and we have the Archean, and we have the Proterozoic. So if you look at these numbers that are in this column I'll look at this grouping right here. So I started off talking eons. The next subcategory is an era. That currently we are in the Cenozoic era. And as we go back through time, I'm looking down on this. We have the Mesozoic, Paleozoic, and we start going back in time. Notice we've already come to this chapter that's back to the Precambrian. Notice that it's within the Proterozoic. So really very recent time, only the most recent 12%, or about 540 million years, is actually non-Precambrian. This is what we call Phanerozoic. And then if you look at how this is kind of displayed here, we've got the Phanerozoic broken out over here. I'm going to go back and finish up a little bit about the Precambrian. The Hadean is actually the idea that the Earth here, the origin of the Earth, this is actually when the Earth formed out of kind of this nebular region, this a bunch of dust and gases and ice and rock and all kinds of materials that coalesced, that gravitated together, and it built a planet. So we'll learn a little bit about Earth's formation and evolution, but Hadean actually means hell on Earth. This would have been a heavy bombardment period, that asteroids, comets, and objects was just a very unstable time in Earth's origin. But it happened, this here took from 4,500 million years ago, which is 4.5 billion years, to about 3.8 billion years ago. For about 700 million years, it was pretty chaotic on Earth. But in this stabilization, the water cycle took off, and plates and continents begin to evolve. Then we have this timeline right here. This is a marker about 3.8 billion years ago, or 3,800 million years ago. But 3.8 billion years ago, this marker right here is essentially where life, the first fossils of evidence of life, are found. So these markers you're going to find are going to be different features that were taking place geologically and biologically, that it's hard to ignore that they kind of coincide. But this kind of triggered a new timeline going from the Hadean to the Archean. And there were different features that were taking place here. We're not going to get into those right here, right now. And then 2.5 billion years ago, it went from the Archean to the Proterozoic. So we've got several different features that are taking place here. And we had an early and a middle and a late Proterozoic. We also have an early, middle, and a late Archean. But just different, what we're looking at right now is just different timelines, that these are broken up by very distinguishable features. So we have eons, the largest chunks of time, then we have eras, and then we have what are called, and we're going to focus right now on the Phanerozoic eon, and we're going to look at the Cenozoic, Mesozoic, and Paleozoic eras. And if you look at this, has been kind of expanded upon, made larger, just the most recent 12%. And these are the eras, right? The Cenozoic, Mesozoic, and in this case Paleozoic. These are broken down now into periods and epochs. And I want to focus here on these different periods of time. So let's go back in time. At the end of the Precambrian, we go right into the Cambrian. So this is our divisor. And this is where we have our first multi-celled organisms that are found in the fossil record. It's a very key time. This is where the Cambrian explosion took place. So we've had all kinds of organisms with shells. We went from all this mud and sediment with very few fossils to all of a sudden this Cambrian explosion took off about 540, 550 million years ago. And this is what's called the age of the invertebrates. This is when invertebrates dominated the Earth, and they were evolving. They were going from like roughly 3 billion years ago, we'll call it, to very primitive single-celled organisms, to now all of a sudden we're starting to get some multi-celled organisms, the first multicellular organisms. So that took over 2 billion years for the cell to kind of figure out what it was capable of. So, that's a lot of death, a lot of life and death in the process of 2 billion years. But within the Cambrian, we have these different events that took place, and a lot of these timelines are broken up as to, well, let's see here. Here we've got our first organisms with shells. Here we have the trilobites that dominate. We'll talk a little bit about trilobites as index fossils. And then we have our first fishes. And then this timeline right here, going from the Cambrian to the Ordovician, within the Paleozoic, this is a divisor here about 443 million years ago, where the Silurian comes into play. And the Silurian is called the age of the fishes. Well, technically, this both Silurian and Devonian. This is where our first land plants began to take off. Our fishes became very dominant, and our first insect fossils were formed. So we've got changes taking place on these in the course of roughly 50 to 100 million year increments. So understand, we're talking millions of years here. So let's not lose focus here. Let's see. So Devonian. So now I moved into the Mississippian. This is called the Carboniferous period. Carboniferous period. These are where amphibians were very abundant. We have these large coal swamps. These are where our fossil fuels come from rock layers that are found in the Carboniferous. These are where our coal, oil, and natural gas seams are found very, very much plentiful in these particular rock layers. So geologists or petrologists looking for fossil fuels would go and find these rock ages, and then they'd look for fossil fuels. So moving back through time, the first reptiles, this is actually a time here of age of amphibians. They were very, very prevalent here. But here I'm starting to have reptiles come about, and then the extinction of trilobites and many other marine organisms. Roughly between the Permian and Triassic period, there was a mass extinction. Tremendous amount of life died, but those who survived led to pave the way for the age of reptiles. So evolution took kind of an interesting turn. So check this out. This is the time of the dinosaurs. Right? Dinosaurs, birds became pretty abundant, flowering plants took over, and dinosaurs were a very successful species. They lived very, very successfully for about 180 million years. We'll come back to that 180 million years, because I would say that makes a successful species. But 65 million years ago, there was a mass extinction as well. And the dinosaurs, there are no more fossils, or many species that are no longer found in sedimentary rock as we enter what's called the tertiary period. So here we have another timeline of Earth, but this here becomes the age of mammals. And the age of mammals are significant. That asteroid that hit the Yucatan Peninsula in Mexico 65 million years ago, probably not good for the organisms that died, for all the reptiles, but I tell you what, it led to the advent of mammals. And mammalians as a species began to take over, and they prospered. And then we come to our more recent timeline. Just a couple million years ago, within the last 2 to 3 million years, humans develop and evolve. So if you think about the total lifetime of primates, right, we are Homo sapiens sapiens, we're less than 2 million years old. Well, okay, we have become intelligent here in very recent times, but think of it this way. In less than 2 million years is all of human history, or hominid history. Dinosaurs lived for 180 million years. I'd say that that's a pretty successful measure until that asteroid hit. And last but not least, to give you today's geologic timeline, we are located, right, currently, we are in the Phanerozoic Eon, we're in the Cenozoic era, we are in the Quaternary period, and we are currently in the Holocene epoch. The Great Ice Age took place in the Pleistocene epoch, and you'll be hearing more about that later. There you have it, geologic time. If you look at the next couple slides here, the breakdown goes through them a little bit more. There have been 2 major eons, Precambrian, Phanerozoic, and I just kind of talk you through what I just went through just a minute ago. I will show you the slides so you can go back and review them. Notice Paleozoic implies ancient time. Life forms were evolving and changing. Mesozoic, dinosaurs ruled. Before 65 million years ago, they were killed off by a giant asteroid. And lastly, humans develop. very, very recently. Within 2 million years ago, our oldest ancestors were climbing literally out of trees onto prairies, and bipedalism, walking on two legs and standing upright, led to the development of the human brain. And that's where your cranium capacity comes in for most of you.